functions, specifically if we're given the graph of a function. It's called the vertical line test. We'll get to the point where we abbreviate that as the VLT. So this is a test that you can do whenever you're given a graph and you're trying to determine whether it's a function or not. So a graph represents a function when no vertical line passes through more than one point on the graph. So first to get our bearings, vertical means up and down. All right? When you're standing, you are vertical. If I can draw a vertical line anywhere on this coordinate plane, and it only touches or passes through the graph one time, it is indeed a function. So if you look at the graph on the left, no matter where I draw a line, and I'll draw the lines in red so they're easier to see. Make this one a little smaller. Not bad. If I draw a vertical line here, or if I draw a vertical line here, or anywhere where this graph is, it's only going to touch in one point. Even if I move this vertical line so it's over a little more, so get rid of this one, I move it over here, it still only touches our graph or passes through at one point. If it passes this test, then we say yes, it is a function. And instead of saying each input has exactly one output, we could just say it passes the vertical line test, or the VLT. The vertical line test basically is checking if each input has one output. We could say here we have an input of, where we're at, 4. The only output is 3, which is where this point is. If I'm looking at, okay, if I put in a 9, x value for 9 on my graph is up here. The only thing out is I'm getting an 8. So counterexample, something that would fail the vertical line test, is a function that would look like this, where if I were to draw a vertical line through the graph, let's just say at this point, it crosses the black lines in 2 different spots. Right here at the point 1, 4. And at this point down below, that's about, 1, -5. So why I'm labeling these points is just to see, now we can say, okay, this fails the definition of a function. 1 has an output of 4. 1 also has an output of -5. Because inputs or outputs can also be represented, like we said yesterday, as points on a graph. So we would just say, no, this is not a function. We can abbreviate function. I'm giving you all the abbreviations today as FCN. That's what function is. Not a function, and then we have to give an explanation. We say it fails the vertical line test. These problems are nice because all you have to do is know what a vertical line is. Just be careful, make sure it only passes once. Passes once, it passes. Passes twice, it fails. So looking at the 3 examples we have, shapes like circles, rectangles, squares will always fail the vertical line test if we put them on a graph. Because if I draw a vertical line just right here, it passes in 2 spots, 2 points, it crosses. Right? Even if I were to draw a point right here, it would cross the 2 points. Even if I go as far on the edge as I can, it crosses at 2 points. Right? So we say it's no, not a function. And why? Because it fails the VLT. Right. Next one we look at, anywhere I draw on my graph, it's only going to touch once. So I just pick one, say, right in the middle. It only crosses that one spot there. It passes the vertical line test. So you can say, yes, it is a function. We know that because it passes the vertical line test. Each input on our graph has one output. All right. Again, these are pretty instinctual. You can just kind of figure it out already. A vertical line will pass twice, here and here. Even if I did it kind of, if I drew it like right in this gap part, that wouldn't count because it has to, we have to check if it passes through the graph, not just anywhere on our coordinate plane. We check if it's going through the parts on the graph. So this is not a function, not a FCN, using our abbreviations, because it fails the vertical line test. Vertical line test, one of the easiest things we'll do all year. All right. So that's kind of topic number 1, the starting topic. More of a continuation of yesterday, identifying functions. Our next piece is we're talking about the domain and range of a function. So domain and range. The domain of a function is a set of all possible input values. We talked about yesterday, our input values are synonymous with x values. So really this is any x value that is listed in our function, whether it's a set of points or it is on a graph. The range of a function is all the possible output values or y values. So whether that's on a graph or again, or in a table. Easy way so you don't get confused whether domain is with x and y. Just think about alphabetically. In the alphabet, D comes before R. Also in the alphabet, X comes before Y. Right? Domain and X values, range, and Y values matched up together. So if you have right now in your pencil bag or whatever, a different color to write with, I'm just going to say that'll be super helpful. It's not necessary, but it'll help you kind of keep track of information as we go through this. So we're simply going to go through, find the domain and range of this set of points. Right? A set of points can represent a function. In this case, it does. Kind of like we did yesterday, we're going to go through and we're just going to label all of our x values. So -2, 3, -8, 5, 8, 7. Those are all x values, so I'm going to put an x underneath each of these. If you don't have an extra color, highly suggest then doing the X's underneath each. And we'll just do this first. So these X values, -2, 3, -8, 5, 8, 7, are all of our possible input values. That's everything that's going into our function. So to write domain, we're just going to make a list of these from smallest to biggest. Right? And what we do when we're listing domain, we kind of have these curly brackets. They don't have to be gray. Make this one a little better. That we put our numbers into. If you just want to even do like solid brackets, they don't have to be the little fancy ones. But we're going to list these now. Smallest number first, biggest number just going from left to right. So our smallest number here, we look through, would be -8. So -8 goes first. Next number, we have a 3, a 5, an 8, a 7, so it'll be -2. So we're just writing -8, comma, -2, comma. Going to the next number, that would be 3, comma, 5, comma, what do we have? 7 and 8 left. 7, comma, 8. So we have all 6 values here. Boom, 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 boom. Now just list it. This is our domain, all of our possible X values for our function. To find the range, we're now just going to look at our Y values. So I'm going to put Y's up here just so it's not confusing. Keep the X's and Y's separated. And again, we're going to have, these are all of our possible output values. These are all the values we can get out of our function. That's what our range is. So again, I'm going to draw 2 sets of brackets, and I'm listing numbers from smallest to largest. Smallest number would be -10, so that goes first. Our next smallest, or our next biggest number would be -7. If you have 2 -7s, you only have to list it once. So if you have a number that repeats, you only have to write it down once. So we have -10, -7, and then this would go -4, -3, just counting up. -4, -3. I'm missing just +7. So I should have 5 of them, one less. All right, domain, all possible X values. Range, all possible Y values. Just making a list, basically. And you're given points. List of X values, your list of Y values. We'll go through this next example a little quicker, then we'll move on to the graphs because that's the fun part. Again, for domain and range, I highly suggest either using different colors or labeling. So I'm just on the back page of where we were just working at. My X values, so I think X values, domain, I'm doing domain first. -5, 0, 6, -10. I just have 4 possible inputs, 4 X values to list. So I draw my brackets, and I go smallest to largest. Sometimes this is just the hardest part, making sure you don't forget a number that's in the correct order. -10. Going up, our next one would be -5. 0, and 6. There we go. That's our domain. All of our possible x values. So let's think. If we go back to our calculator, not calculator, vending machine example. Vending machine, not calculator. Think of these. Say you only have 4 buttons on your vending machine. Your domain would just be the 4 keys. If you only have 4 snacks coming out, let's say like we're talking, I don't know, Hot Cheetos, Doritos, Fritos, Lay's. That would all be in your range, your 4 possible snack outputs. Since we're talking numbers, let's list these. Again, smallest to largest, -8, 1, 4, and 8. All of our range. When you're given points, it's nice, making 2 lists. Looking at these graphing examples, they're a little tougher. And why that is because we don't have what we call kind of discrete points. We can't just say this number, then this number, kind of going by holes. In this function here, we're including every point on this blue line. So that means we can include the point like -2.67, -2.66, -2.65. We don't want to have to list every single value in here because there's an infinite number. So instead, how we get by that is writing an inequality. So let's again focus on domain. We're looking for the possible x values that can be a part of our function. To do that, we have to look at, okay, what's the smallest x can be? Following our line here, we look down to the x-axis of our graph. Numbers to the left get smaller, numbers to the right get bigger. So I'm looking for the smallest number. I'm looking over here and looking as far as my dot goes. So my dot is right above -5. Right? We keep that number in our brain. -5 is the smallest our function is going. Then we just read across and we say, what's the highest our x value goes? Well, we line up underneath where our dot is and look down. That value is 3. So we can include every x value between -5 and 3. We know how to write that as equality because that's what we spent all last unit on. We're going to say we want x to be between -5 and +3. And also notice here we're back to having closed circles. Just looking at some of the following examples, you'll see they have open circles. So that means we can be exactly equal to -5 and +3. So we're going to write our inequality as this. Our smallest number, -5, -5 is less than or equal to x, and less than or equal to our higher number, 3. So we're saying our x values can be between -5 and +3 inclusive. Right? We can include both of these values. Sometimes you'll see people go, they kind of write like kind of the boundaries, like it goes from here to here. -5 less than or equal to x less than or equal to 3. If we're talking about range now, we're going to talk about it the same way. We can include all the y values, but now we're looking at y values, so we're looking up and down. Our lowest point on our graph is right here. We follow it, boom, 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 boom. Our highest point is up here. So essentially, we're going now from our low value of 2 to our high value of 7. We can include any y value in between 2 and 7 inclusive. So we're going to write that inequality as our low number, positive 2, we're talking about y's now, and then our high number, 7. So we're finding kind of thing when we're writing these, we're finding the bounds. We're kind of finding the lowest x can be, the highest x can be, writing an inequality. Same thing for y. The lowest it can be, the highest it can be, writing an inequality to match that. These are tough. Best way to get these is just more practice. We're going to do another one. What I want to point out, though, is now these are both open circles. So when we're talking about our x and y values now, we can't include the values that are here. So I know instead of less than or equal to, these are just going to be less than. So a nice way with domain and range, if you can understand what a closed circle versus an open circle means, you can fill in about, I don't know, 50% of your inequalities. I know that this one is going to look like this. It'll always be the same. I don't have the bar underneath because I have open circles. Same thing for y. I have open circles, so it should look like this. Now, all I need to do is find my high and low number for x, my high and low number for y. And again, that's all from the graph. So x looking across the x-axis, I'll do that in red. Our low value is at 2. Our high value is at 11. When we're looking at our y's now, we have to figure out, okay, what's the highest our y can go and the lowest our y can go. It's not always going to match up to where our points are. So our lowest is -8. That's the lowest it dips down. The biggest or the highest it goes, we look, okay, where's our kind of our crest of our graph? It's at 7. So then we fill in. -8, 7. And I goofed up on one thing. We're going to go back to it. I just noticed what I did. So we only have to worry about opens and closed circles when we're talking about our x values in some cases. In this case, since this is a solid line, all right, that means we can include the value -8 as a part of our inequality and 7 as a part of our inequality. So we have to put lines underneath here. Most of the time, probably, I think all the examples that we have, your range will always be less than or equal to for both. Right. All right. I can include, if we look down from this dot, I can include -1. So I could say -1 is less than or equal to x. When I look on this side, my high number, I'm below 10. Since 10 is an open circle, I cannot include x. So I just write x is less than 10 without the inequality bar underneath. Right? This would be a level of like a spicy question where you have to keep track of both open, close, open circle, close circle. Range is still going to be the same. Find your highest point, find your lowest point. My low point here is actually one of our circles, okay? So this is where it can get confusing too, and it's a spicy question. Because our open circle is our lowest point, so we can't include that point. We have to use our less than symbol. So this is -6, and we're not including -6 in our range. So we have to say -6 less than y. But when we look to our highest point, it's a closed circle, so we can include that point. So we would say less than or equal to 10. Oop. I don't know why it's writing down there. Less than or equal to 10. That's supposed to be in line. I think that's a sign telling me to stop writing. Stop talking.